All right, so we spent quite a bit of time with arithmetic, and the arithmetic is important. Uh, do stay up to speed on that. But now it's time to take another tack, and we're going to get into some of the history. We're on page 35 in the lab manual. Right at the top is a quote by my favorite author of all time, Robert Heinlein. He says, "The three-legged stool of understanding is held up by history, languages, and mathematics. Equipped with these three, you can learn anything you want to learn, but if you lack any one of them, you are just another ignorant peasant with dung on your boots." Oh boy, that's kind of harsh, but there is quite a kernel of truth in that. Too oftentimes, I believe, science is taught as just this litany of clinical facts and factoids that one must memorize and regurgitate. And as I've mentioned in other outings, science is as human as it gets. It's the most human of all endeavors. Science is about understanding things. Who does the understandings? Well, it's humans. So yeah, it's as human as it gets. So it's important to understand how we got to where we are here and now in the 21st century. And believe it or don't, what took place centuries, even millennia ago, has a bearing on what we do now. So page 35, we're going to go all the way back to a gentleman by the name of Aristotle. You may have heard of him. First, a few factoids. Number one, roughly 2,500 years ago, that would put him, at roughly 500 BC, give or take a century. We're not going to worry about being all that exact. It puts you in the right era. Number two, you may not see this written in so many words, but we can certainly make the case for this one. Father of scientific reasoning. Not the scientific method, that comes much later. But yeah, father of scientific reasoning. He was a Pythagorean. Which is to say, he was all about logical inference, and deduction. He was a teacher, and included in his curriculum was this. He taught geocentrism, which is to say that the Earth was the center of the universe. A few other things. He tutored Alexander the Great. He focused on what could be directly observed with the five senses. And just to expand on that idea, the Pythagorean idea. The Pythagorean protocol. Yeah, that's a whole lot of stuff to unpack. The Pythagorean protocol. Any observation in the natural world should be explained and understood by logical inference and deduction. So let me go through this. So we're talking about roughly 2,500 years ago, roughly 500 BC, give or take a century, in what is now Greece. But there wasn't a country named Greece back then. It was a bunch of city-states. Nevertheless, there was what we now regard as Greek culture, and it was really at its peak. This is the birthplace of representational democracy. This is the place of the great thinkers, Plato and Socrates, and yes, Aristotle and Euclid, and yes, Pythagoras. Pythagoras, you may recall from your high school days, the Pythagorean theorem. A squared plus B squared equals C squared. Yeah, that's the same Pythagoras. Pythagoras was a mathematician and also a philosopher. So at this time, there's this explosion of everything intellectual that you can imagine in terms of mathematics, in terms of philosophy, in art, in architecture, in theater, and this kind of comes under the heading of the more things change, the more they stay the same. Here in this information age, we are faced with this glut of information that now is suddenly available to us. It's oftentimes referred to as trying to drink water from a fire hose. Well, in kind of the same way, that's what's happening back then. There is all this stuff going on. And where does Aristotle come in? Well, he's one of the great thinkers of this time, and he says there's got to be some type of a protocol, some type of a way that we can manage this way of thinking about what we would now call science. And so this is where he comes up with this idea from the Pythagoreans about logical inference and deduction. Now, a lot of confusion about the word inference. So just to be clear on that, if I imply something, you infer its meaning. That's where that one goes. Now, the Pythagoreans also believed that there should be at the base of it a mathematical explanation for that which we observe in the natural world. it's an amazing time. It's an amazing time, and it reads into so much of what we experience even today. If you ever took a geometry course in high school, I promise you, the textbook that you had in high school was a direct descendant of a book written by a fellow back in this general era by the name of Euclid. That's why it's called Euclidean geometry. Euclid's Elements. This book is still in print today. It is the longest continually published book in civilization. Believe it or don't. If you like going to the movies or watching a movie on Netflix, you like watching stories, that's theater. This is where theater, as we understand theater, began. And I like to tell this little sea story. My last overseas tour was in Sicily. And often on the weekends, I would rent a little Fiat and go bimbling around the countryside in Sicily, and just to see what I could see and explore what I could find. So I was going through this little small town, and you have to remember that at one point Greek influence extended all the way through to Italy and Sicily. And so I'm going through this little town, and there is, in this small town, there is an ancient Greek amphitheater that has been restored. So you have this kind of like a little bowl-shaped affair, like a little gully with these stone benches for the audience and a stage down in front. And so I said, well, okay, I'm going to watch this. And they were staging one of the ancient Greek plays from that era. Now, I couldn't speak the language. Didn't matter. You could pretty much figure out what's going on. And boys and girls, I'm here to tell you, just in case you thought that X-rated was invented in just recent times in the 20th century or even more recently, let me tell you, no, we did not invent X-rated. I'm watching this play, this play that's over 2,000 years old. I'm a sailor and I'm blushing, all right? So this is where, so much of what we experience today has its beginning way back then. It's also important to understand, though, where the limitations were. There had not yet been invented that which we now call optics. Optics have not been invented yet. So those of us who wear glasses, or those of you who wear contact lenses because you don't want anybody to know you have to wear glasses, you know who you are, all right? If you lived back in that time, you got to know what you would be. You would be blind, squatting on a sidewalk with a bowl going, alms for the blind. That's what would have happened. Or something else to think of. Have you, or do you know somebody who has had their appendix out? What would have happened back then? Well, they'd have died, because medicine is virtually non-existent back then. Not much in the way of technology. Some plumbing for the rich folks, and that's about as far as it goes. So, nevertheless, there is this explosion of knowledge and the beginnings of what we would now call science. And that gets us to this idea of geocentrism, or the idea of the Earth being in the center of the universe, and how it fits in with this Pythagorean protocol of thought and the five senses. Now, I could say to you, if you got up early enough this morning and looked at the east, what would you see? You would probably say, oh, I saw the sun rising. Well, did you really? And you would say, well, no, actually the Earth was rotating and gave the impression of the sun moving, which we know. We got taught that back in grade school. Well, they didn't know that back then. And what Aristotle is saying, what the Pythagoreans are saying, is what is it that you can absolutely swear to in a court of law, given what your five senses are telling you? And the only thing that you could see was the apparent motion of the sun coming up from the east, or in the evening, the moon coming up from the east. Despite the fact that if you do a little back of the envelope arithmetic, it turns out that here we are at roughly 45 degrees north latitude in the state of Maine. and the Earth spins around once every 24 hours. The arithmetic comes out to we're going just a little bit over 700 miles per hour spinning around right now. And can you feel that 700 miles per hour? No, obviously you cannot. So there's nothing in your five senses to tell you that you are in motion. Not directly. Not directly. The only thing that you can swear to is the apparent motion of celestial objects. And so this makes perfect sense, given what they have available to them. Now, I mentioned the technology and I mentioned optics. The reason that I mentioned optics is because if we don't have optics, that means that we don't have telescopes. Telescopes are a long way off. So how do you do astronomy back in those days? Mark 1 mod 0 eyeball. That's it. That's all they got. So given what they had to work with, it's reasonable to see, it's a reasonable conclusion based on their hard-nosed, hard-boiled observations. Not bad. Had Aristotle left it at that, it would probably be more acceptable from our viewpoint here up in the cheap seats in the 21st century. But he didn't. Aristotle then went on to say that it is axiomatic, that is self-evident, that man is God's greatest creation. And therefore, logic would dictate that God would not place his greatest creation in any place but the center of the universe. So Aristotle invokes deity as a scientific rationale. And again, from our perspective, we would tend to say, what? But wait. This is perfectly acceptable back then, because all of these disciplines, whether it's literature or mathematics or science or theology, all go into one big bucket called philosophy. So that means that everything's fair game. You know, there's no lines of distinction between the different mental disciplines. So it's a perfectly acceptable premise. I mentioned that he tutored Alexander the Great. That's a little bit of trivia, but it's kind of interesting, I think. This is a time, as I mentioned, that there are all these different city-states. And what that means in practical terms is you couldn't swing a cat without hitting a prince or king or some type of royalty. One of these royals, King Philip, decided to have his son receive the best possible education. And it would have been like Queen Elizabeth sending one of her children to be educated by Stephen Hawking. That sort of deal, or one of her grandchildren, I'll get my times right. Sending one of the grandchildren to be educated by Stephen Hawking, sort of that idea. And so Prince Philip had his son, wanted his son to receive the best possible education, and that was Alexander. So Alexander was personally educated by the great Aristotle. And sometimes if we hear about how teachers should be assessed, and there's a recurring theme that we hear often is that teachers should be assessed by their students' success. And certainly we could have that discussion. But if we were to assess the effectiveness of a teacher by student success, well, there's some student success right there. Alexander the Great, considered by many to be the first modern educated military leader. He was brilliant, absolutely brilliant. So much so that his campaigns are still studied in military academies like West Point to this very day. They study the campaigns of Alexander. If you are a bit of a history buff, World War II, I promise you that Field Marshal Erwin Rommel and General George Patton were both students of Alexander the Great. Yes, they were. Now, Aristotle also had some other interesting ideas. One of them was, this is just kind of trivia, kind of fun stuff. He believed that if you threw a ball through the air, like so, that the air would go around the ball like so. Well, yeah, it does. But not only that, says Aristotle, he says that the air would come around like that and kind of give the ball a little extra push. You know, it almost kind of makes sense, but no, it doesn't really work that way. Another one of Aristotle's ideas was that heavy objects fall faster than lighter objects. Well, let's give that a test. So here I have the laboratory rock and a piece of paper, and so we'll drop them side by each and see which hits the floor first, and lo and behold, the rock hits the floor first. Looks like Aristotle's right. But wait, there's more. Okay, here's the rock, same piece of paper. So I'm going to crumple it up, and I want you to try this one at home. Go ahead and try this. Grab yourself a rock and a piece of paper. So now here's my piece of paper. I haven't changed the weight at all. Okay, so it has the same weight. I've just changed its shape, and we'll drop them at the same time, and what do you know? They'll land exactly side by each. Believe it or not, it took over 2,000 years for us to get that one squared away when a local smartass by the name of Galileo went to the top of the tower, Leaning Tower of Pisa, and dropped two iron balls, a big one and a little one. Dropped them the two of them side by each, and down they went and hit at exactly the same time. So there you go. All right, so that's Aristotle. All right, we'll stop here and then we'll go on to the next page.